Dear students, today we are going to start with the first chapter of 12th physics, that is electrostatic. Now let us start what actually the electrostatic is. Electrostatic word can be divided into two parts, right? The first word is electro and the another word is static. Electro means the charge and static means at rest, right? So in this chapter we will be studying electro means the charge, static means at the rest. So in this chapter we will be studying about the charges at rest, right? Now first of all you should know what is charge, what actually the charge is. What is charge, right? Charge is the property of the material which make it possible for them to exert electric forces and to respond to the electric forces, right? If you have a neutral atom, it means that the number of protons are equal to the number of electrons, right? As the number of protons are exactly same as that of number of electrons, the body will have no charge, right? As all the neutral atoms are hydrogen, helium, copper, neon, when you don't provide any kind of electron and when you don't fetch out any electron, it means that your body is neutral. When the number of electrons increases, when in any system, any material, the number of electrons increases. For example, we have taken the case of chlorine, in which we have added one electron, then it becomes chlorine negative. When the number of electrons increases, due to increase in the number of electrons, your body has acquired negative charge. Similarly, if you take out the electron from the material, as we have taken out one electron from the sodium, it has acquired positive charge, right? So how the charge appears? The main reason for the charge appearance is the imbalance between the number of protons and number of electrons in the system, right? It will acquire negative charge if you give extra electron to it, and it will acquire positive charge when you take out the electron, right? So depending upon the above discussion, we can say that the charges are of two types. The first charge is the positive charge and the another charge is the negative charge, right? So charges are of two types, and what are the various kind of forces between the charges, right? If you have like charges, right? For example, we choose two like charges, we choose positive and positive. These are like charges because they both are positive, right? So like charges repel each other. The like charges repel each other, right? As you can see in the figure A, we have two positive charges. They are repelling each other. Similarly, the like charges are negative charges as shown in figure B. They are again repelling each other because the bobs are moving away from each other, right? The third charges are the positive negative charges. One charge is positive, another charge is negative. They are unlike charges, means one of the charge is positive, another charge is negative, right? So the unlike charges attract each other, means if you talk about the same charges, like charges, then they have, like charges have repulsive forces between them, while the unlike charges have attractive forces between them. Unlike charges have attractive forces between them, as these two bobs, one is of positive charge, another is of negative charge. They are coming closer to each other, and this closeness is due to the attraction, right? So we can say that the like charges repel each other while the unlike charges attract each other, right? The property which differentiate between the kind of charges, that is the positive and the negative, this particular term is called polarity, right? So the charges means the charges has polarity, due to which they distinguish between each other, right? Next very important topic of this chapter, that is about the quantization of the charge. Quantization of the charge is the most important topic. You will find numericals from this topic, as well as this can be asked as a short question in your board exams, right? So what do you mean by quantization of charge? If you want to explain the things in a simple manner, quantization means when you will have something in a fixed amount. Quantization means when you will have something in a fixed amount, right? So we have written this equation which says that Q is equal to NE, right? This equation is the equation for quantization of the charge, right? Where N is an integer, N is an integer and N can be positive as well as negative, right? N can be positive as well as negative. There is no restriction on the N that it should be positive or negative. N can be both positive and negative. The only condition on N is that it should be an integer, right? So N cannot be a fractional. It cannot have decimal values. So if you take your N is equal to 1, then the charge is Q is equal to plus minus E. If N is equal to 2, then the charge is plus minus 2E. If N is 3, then the charge is plus minus 3E, right? Where E is the charge on electron or proton. The basic value of the E is, that is 1.6 into 10 raised to the minus 19 coulomb. Coulomb is the SI unit for the charge, right? So it is important to understand that the charge will be always multiplier of E, integral multiplier of the E, right? So if you now define the definition, the quantization of the charge is the property by virtue of which all free charges are integral multiple of basic unit of the charge. Basic unit of the charge is charge on electron, and the value for charge on electron is 1.6 into 10 raised to the minus 19 coulomb, right? So from here we can say that the charges in which N is not an integer are not possible, right? If you will have your N as a non-integer numbers, for example 0.25 is non-integer because it's a decimal number, 0.33, any number, it can be 36.928, 40.46, any number which is not a complete integer, that cannot be the value of charge. Let us do a problem. The problem is charge 6.4 into 10 raised to the minus 18 coulomb possible? Can anybody, any material can acquire this particular value of charge, right? So let us calculate. Okay, so we start up with the equation which is for the charge quantization, which says that Q is equal to NE, right? Q is equal to NE means N is equal to Q by E, right? the value of charge from the question is 6.4 into 10 raised power minus 18, and the value for E is 1.6 into 10 raised power minus 19. You need to remind this value, right? If you do that, 16 times 4 is 64, so it comes out to be 4 into 10, which comes out to be 40, right? So 40 is an integer. Your n comes out to be an integer. It means that yes, 6.4 into 10 raised power minus 18 coulomb charge is possible. So this value of charge is possible. Now, in the next problem, let us try this particular charge. Is it possible? Right? To try that, we again write Q is equal to NE. Quickly, you can do it earlier than me. So, N is equal to Q by E. Then we substitute the value of charge, that is 3 into 10 raised power minus 17. Then we know that the value of E is 1.6 into 10 raised power minus 19. Right? So by doing the calculation, we have equal to into 10 raised power minus 2. Right? So this will be about 237.5. This 0.5 has created a trouble. So this is not an integer, it's a decimal value, right? So no, this charge is not possible. This charge is not possible, right? So the provided value of charge in the question is not possible, right? Then the next question is, what is the total charge on 75 kg of electrons? If I provide you 75 kg of electrons, what will be the total charge on them? Right? So what you are provided? You are provided 75 kg of electrons, right? And what you know? You know that mass of electron. You know mass of one electron, that is 9.1 into 10 raised power minus 31 kg, right? So this is the mass of the electron. Then number of electrons can be calculated. Number of electrons can be calculated, that will be 75 divided by 9.1 into 10 raised power minus 31, which comes out to be 8.24 into 10 raised power minus 10 raised power plus 31, right? So these are the number of electrons. Then the total charge will be Q is equal to NE. You know the value of N, that is plus 31, right? Then you multiply it with charge of electron, that is 1.6 into 10 raised power minus 19. On simplification, you get it equal to 1.3 into 10 raised to power 12 coulomb. So this much charge will be acquired by 75 kilogram of electrons, right? Let us discuss additivity of the charge, right? So you should know how to deal the system if it is consist of multiple number of charges. You have a system which is consist of multiple bodies and they have different charges, right? Say that the bodies have charges Q1, Q2, Q3 up to Qn. You can take a simple example that you have some enclosure, that you have a box in which the charge bodies are there. The first body has a charge Q1, second has a charge Q2, and next has a charge Q3 and so on, right? And we know that the charge is additive in nature. This is important, that charge is additive in nature. So the total charge will be given as Q1 plus Q2 plus Q3 up to Qn in addition, right? So the total charge will be sum of all these charges, right? So to do that, we take a simple example. What we do, we suppose that we have a body, we have a system in which Q1 is minus 2Q and Q2 is 3Q and Q3 is minus 4Q, right? So these are three different charges in one system, right? And we need to calculate the total charge of the system. We say that the total charge is Q. So what we will do, as per the additivity nature of the charge, we will write Q1 plus Q2 plus Q3. Let us substitute the value for this is minus Q, plus Q2 is 3Q and Q3 is minus 4Q. So the total charge on the system, it will be minus 6 plus 3, it will make it minus 3Q. So the total charge is minus 3Q. So as per the additivity of the nature of the charges are added directly